We have a few different properties. We have the commutative property. I'm just going to, like I said, jot it off on the side here. Commutative. So these are properties. We have the associative. Distributive. Identities. And inverses. All right. We have two types of commutative property. We have the commutative property of addition and we have commutative property of multiplication. There are other operations that exist that have what we call commutativity. Sorry, I missed a syllable there. But they're a little bit more advanced than the four basic operations. All right. We learned yesterday that it does matter what order you subtract numbers or divide numbers in, but it doesn't matter if you're using addition or multiplication. So the rule here would be A plus B is equal to B plus A. All right. So I'm going to simultaneously with using the pencil paper approach, I'm going to use Desmos to draw up a little, I'll call it a cheat sheet for you, using some notes. We have commutative property. And we just came up with a relationship where A plus B is equal to B plus A. And it'll expand a little bit here. A plus B is equal to B plus A. So the benefit of doing it this way, and I'll just kind of move the sliders up to the top, because I'm going to use these for a bunch of different properties. The benefit of doing it in Desmos is that I can see that regardless of where I put my B value, regardless of where I put my A value, the result is always the same. A plus B and B plus A are the same thing. If you want to put it, make it look a little nicer, fraction form, you can do that too. All right, but that's an example of the commutative property of addition. We also have the commutative property of multiplication. A times B is equal to B times A. All right. So I can write that using multiplication symbol. Or I can write it just where the A and B are adjacent to one another. All right, that would be the same thing without multiplication. You put two letters next to each other, it's implied that they're multiplied. All right, so B times A. So we have, for addition and multiplication, no matter where I put my slider, those values are always going to be the same, whether it's for A or B. All right, so we have the rule, and we also have a justification for the rule. All right, now if you want, I probably should have done this already. You can make a little folder out of this. And we'll go the commutative route for that folder, get rid of that one, and then just link it up. Drag the little command line up so that vertical line appears, and it'll, I hit the wrong thing there. It'll link it all together into the same folder so that you don't have this big old messy Desmos. All right, and this will get saved and posted on Schoology and available to you. All right, in fact, I'm going to save it now so I don't forget. Properties of numbers. All right. So then we have associative. Associative talks about association of numerical values and how they relate to one another. So we have the associative property involving addition, A plus B plus C, where the A and B are grouped together, versus A plus B plus C, where the B plus C are grouped together. All right. So it's just changing the groupings. So this would be associative. This is weird. Why is it doing? Okay. Will that work? Oh, look at that. Now I want to hit enter, so that's kind of an issue, but oh yeah, I see. Oh, not there. So I'll just pop these rules in, but you see now I have a C. All right, so I'm going to say parentheses A plus B. And you're like, there's no slider for C. Well, once I type in the C, Desmos won't know what it is. It'll ask me for a slider. And I'll say, absolutely, I would love to put a slider in there. All right. Who doesn't like sliders? I don't know. So A plus parentheses B plus C. And you see, no pun intended, that regardless of where I put the sliders, whether it's for A, B, or C, the result is always going to be the same for both of those computations. All right. So that's something that you're familiar with. It's the Desmos part of this that you're probably not as familiar with. All right. So going over the techniques, but I'm also going over with you how you can use Desmos to your advantage. All right. Distributive property. Oh, sorry. Associative property and multiplication. Ooh, boy. A times B times C. A times B times C. All right. So you can go a couple of different routes with this. You can type it all in again, or you can hit that little gear icon, which allows you to duplicate. So that's what I'm going to do here. I'm going to duplicate each of these commands and then go back and replace the additions with multiplications. You could write it like this if you want. A times B times C. If you put numbers adjacent to one another or separate them with parentheses, it's the same as saying multiplies. But if you really want to accentuate it, at least for the note-taking part of it, just pop in the little multiplication symbol. All right. And then again, slide your sliders. I'll just kind of move them around a little bit. Get this off of 0. And you'll see that the numerical values are the same in all cases. Now, if you don't want to go back and forth and have to worry about sliding the sliders just to see what's going on, you could animate them. It's just it goes kind of fast. All right. You could slow down the rate at which they go. But it's still going to go pretty fast. All right. So you see it's still kind of flying through, but at least you can get a sense that the numbers are pretty consistently the same. All right. So some people like doing it that way, some people don't. It's really up to you. All right. So that's associative. Then we have distributive. Distributive property of multiplication over addition. All right, so that would be A times B plus C is equal to A times B plus A times C. There's only one variation of that, at least as far as we're going to go in this part of the course. So we would say distributive and then we would just put this rule in. Now, again, you can manipulate something that we've already done, but sometimes you find yourself erasing like most of it. So I'm just going to type it in again. A times B plus C. We don't need fresh new sliders because we already have A, B, and C accounted for. So AB times, oh, sorry, not times, plus AC. All right. Oh, sorry, it's not a whole equation. Oops. AB plus AC. All right, and you see that those values are identical, and you, okay, maybe you don't see. Okay. So now you see. Those values are identical. If I move the sliders at this point, hopefully you believe me. If I move the sliders, you're going to get the same value consistently across the board. All right, so now we have distributive property. All right, next up is identity. Identity is pretty simple. It's just that if you take any value, we'll call it A, and add 0 to it, you preserve the identity of the value A. All right, A's identity remains the same. All right, so this is what we call the identity element. Because that's the number that preserves the identity through addition. All right. So if I take any number and add 0 to it, I'll get that same number. For multiplication, that identity element would be 1 because that's the value that preserves the identity of the numerical value that you start with through multiplication. All right, so in my next folder, I'm going to say identity. Oh, actually, I want the keyboard here. I can just do it this way. Oh, why is it going up there? That's why it keeps jumping up where I don't want it. I want it here. Scroll up. Make it a little wider. Alright, so we had A plus 0 is equal to A. We add A times 0, A times 1, sorry, also equal to A. In both cases, they would give you a result of A. No matter where I put my slider, still going to give the same results. So I'll just kind of move them around a little bit. Same results across the board. All right. Now the inverse is a trickier one because it's a little bit more conceptual. Inverses are values that when operated will result in the identity. All right. So we have A plus I for inverse, is going to be equal. I'll actually use capital I there because lowercase I actually means something else. Equals 0, and A times I equals 1. So it is the number that when added to or multiplied by another number gives the identity element as a result. So it's looking at identities but in a different way. All right, so these are our identity elements. And this requires us to actually solve equations. All right. In some cases, the equations are very simple and easy, but in a lot of cases, they're a little bit more complicated. All right. Now, we could actually, in the case of additive and multiplicative inverses, we could actually figure out what they would be in general terms. All right. So the additive inverse, I'll just, I'll go with the folder, inverses. The additive inverse would be that A plus negative A is equal to 0. All right? Negative A is the inverse of A. All right? So I would say here, negative A is the additive inverse of A. All right, then we would have A times 1 over A. Giving a result of 1. So that tells us, again, I'll use a little note here, 1 over A is what we call the multiplicative inverse of A. All right, so now you have a nice Desmos. I'll fold this up and I'll put it into Schoology for you. You'll have access to it. It's a good study guide. It's a good resource when you're taking tests. Desmos is available to you when you take a test. So if you don't want to use it, you don't have to use it, but it's there for you. All right. So all of this stuff is good to go. And what I do is I share it. And let me actually open it up on this screen. So I share it, and I put it into the spreadsheet that you find online. All right. So properties of numbers, open the graph. It's all there. Oops, this one didn't get linked up, so let me fix that. There we go. Looks a lot nicer now. Then I grab this little share link, copy it. Now I have this nice spreadsheet that you go to whenever you need links. So this is page 6 in Unit 1. And there's the link. All right, so you have access to it when you go into Schoology. So in Schoology you have Desmos links. You see that it's there now. Okay, so that's there for you. So with that in mind, you should now be pretty able to answer these kind of questions. All right. So, number 1, which choice shows the distributive property? So if you follow the model, distributive property is telling you to take the A and multiply it by each term that's contained within the parentheses. All right. It's one thing to have a rule. It's another thing to know what that rule is telling you. So it's asking us, well, which choice shows the distributive property? Well, first off, I'm not in love with the way this is written. So I'm going to write this, because of the commutative property of multiplication, I'm going to write this as 8 parentheses 7 plus A, and then distribute the 8. 8 times 7, 56, plus 8A. All right, so that would be choice 2. All right. Number 2 is asking us to apply some properties, one of which is the distributive property. So I would distribute the negative 3. And then simplify. All right, one thing we didn't talk about, because you've been doing it for years, is order of operations, PEMDAS, or GMA. Maybe they talk about that in the middle school, I'm not sure. But we tend to use PEMDAS, like the whole world uses PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So there's no parentheses, there's no exponents. We've already taken care of multiplication. There's no division, so we're up to addition, subtraction. So we work from left to right and say, okay, well, I can't add these two together or subtract because they're not like terms. Oh, sorry, I'm missing the X. But I can add or subtract these two together because they are like terms. All right? In which case, I would just keep the negative 15 and combine these two. And say, okay, well, what's negative 3x plus 4x? Negative 3 plus 4 is 1, so plus 1x. One x or just 1. All right, you don't have to go and worry about leading coefficients or anything like that. When it's a 1, you can drop it if you want. Now, so that's what my instincts told me to do, but now I'm looking at what I see here in terms of choices. Well, I would love it if there was a negative 15 plus 1x, but there isn't. All right, so they must be after something else. So taking into account that the distributive property is something that should be applied, we can go back a step. All right, so I'll hang on to this because this is good to know. And we'll focus on just this expanded form. Get rid of this stuff. And think about, all right, well, which one of the choices most closely resembles what we wrote here? Because maybe we didn't have to go that extra step. It's good review, but maybe it wasn't necessary for this problem. All right, negative 15 minus 3x plus 4. Well, when we solve this, plus 4x, I mean, when we solve this, we solved it by grouping the negative 3x and the 4x together. All right, so this is essentially what we did. We said, all right, let's take these two and put them together. All right, I just tuck a little plus sign in front as a connector. All right, because it's really negative 15 plus that expression. All right, so what we did was we simplified, but maybe all they're looking for us to do is apply the commutative property where we would just swap the order. So negative 15 at the end, but the expression in parentheses coming first. Maybe they wanted us to do something like that. So now I'd look for that expression if that's available. All right. It kind of sort of is. Number 3 is like right in that neighborhood, but it looks a little bit different. All right. So the associative property tells me that I can swap, or I can move parentheses around. So what if I said, okay, well, instead of grouping these two together, what if I change the order of some things first? All right, so going back to this. All right, so apply the commutative property and then the associative property. So let's change the order and say, okay, well, if I suspect it's number 3, I want the positive 4 to come first. Then I want the negative 3 to come first, to come second, and then I want the negative 15 to come at the end. So I'd ask myself, all right, is there a way of representing this using parentheses? And I would say, well, yeah, I could put parentheses wherever I want. If I put them here, then I pretty much have it. All right. So you could get like 10 different correct answers, but none of them would be the correct choice. All right. In this case, the correct choice is 3, but sometimes you don't know that going in. All right. So if you're in doubt, use a calculator and throw in some values for A and see which one gives you equality. All right. So take the original expression, type it in, take one of the choices, type it in, and see if it gives you the same result. All right. So number 3, under the associative property addition, the expression will become, right, it's just moving parentheses around. So we're looking at number 3. All right, because all I'd have to do is just swap the parentheses, put them here instead of where they were, and it would be equivalent. All right, it's all addition, so it doesn't matter. According to the multiplicative identity, so this is kind of an extension on that. So I go, if I'm not sure, I go back to my little handy dandy Desmos here. I'll take the previous one and look at the relationship for multiplicative identities. 1 over A is the multiplicative, multiplicative inverse. If I want to get a result that's exactly the same as what I started with, it is identity, then what I would say is, okay, well, I want this to be x plus 7. I would ask myself, well, what do I multiply this whole expression by so that it never changes? Well, 1. Multiply by 1 and there's no change, so also number 3. The additive inverse. We're starting with A minus B. We have to add something to that in order to end up with a 0 as a result. So in order to end up with the additive identity. So all we need to do is figure out what that expression would be and we'll be good. Sometimes it's easier said than done, but if you want terms to cancel out means adds to the identity. I have an A, I don't want the A. So I would subtract that. I have a negative B, I don't want that either. How do I get rid of a negative B? Add a B. All right, and if you're in doubt, you can type it into Desmos and check it, but I'm looking for the one that says negative A plus B, that's number 1. All right. So in the case of number 6, you see the parentheses tend to throw people off a little bit because you think associative, you think distributive, but in this case, the only thing that differs from left to right is that they change the order of the sum contained within the parentheses. You change the order of a sum, changing order is commutative. All right. So, commutative property of addition. In number 7, we're looking at the value of 3.5a never changing. Through addition, it never changed. All right, it stayed the same. So that must make this the identity element. The act of operating using the identity element is known as the identity, just the identity, or the identity process. All right. So this is we used addition, so it's the additive identity. Associative property of addition. Well, first off, I'd be looking for one that involved only addition, so let's get rid of this one. This is commutative. The number 4 is commutative, it's just changing the order. This one appears to be inverse because we're looking at taking a number, adding something to it so that you get to the identity. So by process of elimination, it would be number 3, but it's also, pretty easy to identify associative property. It's really just a matter of changing the order. Changing the location of the parentheses. All right. So that was page 6. This is ideally the kind of thing that, I'll just say it, in the past, I would come into this course knowing that everybody knew all of this information. All right? It was just a given. Even people who struggled in math before knew this stuff, but I'm just taking a more careful approach this year, at least in the beginning, because I can't take that chance, because this is such necessary vocabulary. I know it's incredibly boring, and I'm sorry for that, but I got to make sure we're all on the same page before we go too far. All right, because then it does start to spiral out of control if you have a weakness in this area. All right, we don't want to get to that point.